Welcome to O'Reilly Maths. This is the Leaving Cert Ordinary Level 2019, Paper 1, and we're looking at question number 4. So part A says solve for x. So we have this equation here. So it's algebra fractions, and it's an equation. So we're going to have a look here at the common denominator of 5, 2, and 10. And then we're going to multiply across everything by that. So the common denominator of 5, 2, and 10 is 10. So I'm going to multiply this fraction here by 10. I'm going to do the same with this one. And the same with this one here. So I'm balancing the equation here because I'm multiplying everything by 10. And by doing this 10 here and this 5, they simplify to give me 10 over 5, which is 2. The 10 here over the 2 simplifies to give me 5 on top here. So it's 5 multiplied by this. And then this 10 and this 10 cancel each other, leaving me with just the 47. So what I have then is 2 multiplied by the 3x plus 1. This 5 here is being multiplied by that plus there by the x minus 2. So 5 times the x minus 2. And then I'm just left with the 47 over the right there because the 10's cancelled. So immediately now I'm left with an equation with no fractions. It's a lot easier to handle. So now I'm just going to multiply out the brackets. So 2 multiplied by 3x is 6x. 2 times 1 is 2, positive 2. Then plus 5 times x is 5x. And plus 5 times negative 2 is negative 10. That's equal to 47. So just tidy up now. So I'm going to collect the like terms, the x terms together, and then the constant terms here together. So 6x and 5x gives me 11x. 2 minus 10 is minus 8. I still have my 47 on the right. I'm going to bring that minus 8 now over here. It's going to change to be a positive 8. That leaves me with 11x is equal to 47 plus 8, which is 55. So now I'm going to divide both sides by the number in front of x, which is 11. Balancing both sides. These 11's cancel, leaving me with x. And 55 divided by 11 is 5. So my answer is x equals to 5. Part B, it says solve the simultaneous equations. X minus 5y is equal to minus 13, and x squared plus y squared is equal to 13. Now the elimination method won't work here because you have an x term and an x squared term, and then a y term and a y squared term. You're not going to be able to eliminate them. So we're going to use the substitution method. So what we're going to do here is I'm going to rearrange the first equation here to make x the subject, and I'm going to substitute that in here to the second equation. So the first equation, x minus 5y is equal to minus 13. I'm going to rearrange this a little bit. So I'm going to bring this minus 5y over to the other side, and it will become plus 5y. Now the reason I do that is because now on the left I'm just left with x, and x is equal to 5y minus 13. And what I can do now is I can replace the x in the second equation with 5y minus 13 because they're the same. As you can see here, x is equal to 5y minus 13. Yellow is equal to yellow. But x in here, in the second equation, I can replace that x there with this 5y minus 13. So that's what I'm going to do next. So I'm going to protect it in brackets when I substitute it in. So 5y minus 13, I'm going to replace the x with that. So it's still squared plus the y squared is equal to 13. So just so that's clear, this is the bit that I substituted in here. So now I'm going to multiply this out. Now be careful, a lot of people just square this 5y and then square the negative 13. But if you've got a bracket multiplied by itself, or a bracket squared, it's going to look like this. 5y minus 13 multiplied by itself. 5y minus 13. And then you still have your y squared is equal to 13. So I've got double brackets that I'm going to multiply. 5y times 5y is 25y squared. 5y times minus 13 is minus 65y. Minus 13 by minus 5y is minus 65y again. And then finally, minus 13 multiplied by minus 13 is plus 169. And then I still have my y squared here is equal to 13. So now I'm going to try and tidy up a little bit. I'm going to gather the like terms. Just be careful when you're doing this. Use a highlighter if it helps. I have 25y squared here. I have y squared there. I've got my minus 65y there and my minus 65y there. So I'm going to tidy them up. So 25y squared and y squared, that's actually 26y squared. Minus 65y minus another 65y is minus 130y. Plus the 169. And then I'm actually going to, in one go here, I'm going to bring this 13 over to the other side, over to the left. It's going to become minus 13 is equal to 0. The reason I'm doing that is I can see here there's a quadratic equation shaping up here. I have a y squared term, a y term, and now constants. So I always want my quadratic equal to 0. So let's keep going. We've got 26y squared minus 130y. And then 169 minus 13 is 156. And that's equal to 0. Now, the question is, what can I divide everything by here? Well, if the highest common factor of 26, 130, and 156, you can keep halving these and see where that gets you. But actually 26 divides into all of these. So 26, you can divide across by 26. So 26y squared divided by 26 is just y squared. By the way, you could just from here, you could use your quadratic formula, the minus b formula, and you'd be able to solve that from there. Get your two answers for y and sub them in to get your answers for x. But I'm going to try and simplify this because I think it can be factorized. So 130 divided by 26 is actually 5. Minus 5y. And 156 divided by 26 is 6. So I've got y squared minus 5y plus 6. So this can actually be factorized. I'm looking for factors of 6, positive 6, that when combined can give me negative 5. So that would be minus 3 and minus 2. Because minus 3 multiplied by minus 2 is positive 6, and minus 3 minus 2 is minus 5. So a bracket multiplied by a bracket is 0. The only way that can be true is if either this bracket here, y minus 3 is 0, or the other one, y minus 2 is 0. Well, if y minus 3 is 0, y must be 3. So that's one answer for y. And if y minus 2 is 0, that means y must be 2. That's my other possible answer for y. So I've got my two y values now. And now I want to know what the x values are, because it's a simultaneous equation we're solving, so we have to find the x value as well. So I'm going to take this first equation. Well, actually, I'm going to take this version here, because I have x here in terms of y. So x is equal to 5y minus 13. So if x is equal to 5y minus 13, I can substitute the y value here of 3 in here. And that's going to give me x is equal to 5 times 3 minus 13. So x is equal to 5 3s is 15, and 15 minus 13 is 2. And in the other situation, when y was 2, if I rewrite the equation, x is equal to 5y minus 13. So again, I'm going to sub this y value here of 2 in here this time. And that gives me x is equal to 5 times y, but y is 2, so 5 times 2 minus 13. That is equal to 5 times 2 is 10, and 10 minus 13 is minus 3. So there are my two x values there. So the two y values, where y is 3 and y is 2, and the two x values, x is 2 and x is minus 3. So that's the simultaneous equation solved. And that's the end of the question.